I'll be talking about the introduction of the experiment. Phase equilibrium refers to the most stable state that a system naturally reaches under certain conditions, such as pressure, temperature, and even concentration. It is an important concept in physical chemistry because it helps us understand how substances behave when conditions change. Understanding phase equilibria is useful in many fields, including chemistry, biology, and even industry, where controlling reactions and solution properties is necessary. In this experiment, we study how temperature affects the diffusion of food coloring in water. Diffusion is the random movement of particles until they are evenly distributed, reaching equilibrium. Since higher temperature increases the kinetic energy of molecules, diffusion occurs faster. Therefore, observing food coloring at different temperatures helps demonstrate the effect of temperature on equilibrium. One of the objectives of the experiment is to observe and compare the process of diffusion at fixed volume and concentration but different temperature. Next is to investigate the relationship between diffusion and temperature. Not only that, but it also helps to relate the observed changes in diffusion rate to the concept of molecular kinetic energy.
So during the procedure, we noticed that the food coloring dissolves way faster in the hot water rather than in the cold water because the higher the temperature increases, it also increases the kinetic energy.
First, we used two transparent beakers or clear glass cups to hold the water so could clearly observe the experiment. Then we used the measuring cup to measure equal amounts of water. One beaker was filled with room temperature water while the other was filled with hot water to compare the effects of temperature. Next, the few drops of food coloring were added into the water so we could see how the colors spreads. Finally, a stopwatch was used to measure the time taken for the food coloring to diffuse in the water. Thank you.
So in this assignment, we'll be seeing if food coloring dies faster in hot or cold water. So on the cup I have cold water and on the left I have hot water that we'll be putting on the dye. So in the back there I have a stopwatch to see which one will dissolve faster, and I'll be pouring the food coloring at the same time here, and as you can see I'll just be putting. So during this time I just started my stopwatch and we can see that on the right in the hot water the food coloring dissolves way faster than the one with the cold water, as the blue it's still dissolving and in the hot water it dissolves faster. After some time, I decided to check on it again to see if it was really dissolving or it just like stuck to the bottom, but we saw that it was still dissolving, and after a long time it finally dissolved. So just keep on checking and checking and checking. After some time I've seen.
So now we are looking at how the temperature dictates the rate of diffusion in liquids. So at its core, this comes down to thermodynamics and kinetic energy. So when we heat water, you are essentially fooling the water molecules, giving them more energy to move rapidly and vigorously. So when you drop food coloring into hot water at 70 degrees Celsius, those high energy molecules collide with the color particles constantly and with great force. It's like a chaotic high-speed game of bumper cars that knocks the color particles around, forcing them to spread out and achieve a uniform mixed state very quickly. In contrast, look at what happens in a room temperature water at 25 degrees Celsius. Because the water molecules have much lower kinetic energy, they move in a slow and steady rhythm. The collisions are infrequent and gentle, so it's like lacking the kick needed to disperse the color quickly. Instead of an immediate swirl, you get a slow streaking or the color simply pooling at the bottom of the container. So essentially, the faster the molecule moves, the less time the system needs to reach equilibrium. It's a direct, measurable relationship between thermal energy and molecule speed. That's all from me. Thank you.
Hi guys, my name is Kirti and I'm going to present my part in this experiment, which is the discussion part. So this experiment shows how temperature affects diffusion. According to the kinetic particle theory, the particles move faster when the temperature is higher. So in hot water, the molecules move faster, so the food coloring spreads very quickly. And in room temperature water, the molecules move slower, so the diffusion happens more slowly. And so this proves the higher temperature increases the rate of diffusion. So the common example would be the sugar dissolving faster in the hot water than the cold water. So that's all. Thank you.
In conclusion, this experiment shows that temperature affects the rate of diffusion in water. Higher temperature increases the kinetic energy of molecules, causing the food coloring to spread faster and reach equilibrium quickly. This demonstrates how temperature influences diffusion and supports the concept of phase equilibrium in chemistry.